All right, so Chapter 5, Lesson 5 is compare and order rational numbers. So here, number 1 says to refer to the number line, and we want to determine if each inequality about the coordinates of the points is true or false. So here's the number line. We have B, F, and M, and we want to know, are these statements true or false? So is B greater than M? No, B is further to the left. B is further to the left, so that is false. So, letter B, we have F is greater than B. So here's F, there's B. Is F greater than B? True. Very good. Here, M is less than F. There's M and F. Is M less than F? False. Very good. And then F is less than M. True or false? That is true. Number 2 says the student council's goal was to raise $50 each week for 4 weeks to have enough money for the school dance. The table shows a difference between the goal and the actual amount raised. Sort the amounts from least to greatest. So we want to go from smallest to biggest, right? From least to greatest. Now remember, when we're comparing, the first thing we're going to do is we're going to compare, if we're going least to greatest, we're going to compare the negatives first, right? So with negative $6.25 and negative $2.45, which one is the smallest? Negative 6.25. Very good. And then comes negative 2.45. Very good. And then we're going to compare the positives, and that's a piece of cake because this one's a 5 and that one's a 7, right? So we're going to have $5.50 and $7.80. And there are the results. So now we are going to compare decimals and fractions. Please make sure you write down your heading. We're going to compare decimals and fractions. And you don't have to write down this sentence. Positive and negative rational numbers can be represented on a number line. You can use a number line to help you compare and order rational numbers. Now remember, on the number line, the further to the left, the smaller the number. So the further to the left on the number line, the smaller the number, right? The further to the right on the number line, the bigger the number. Okay, so you can use a number line to help you compare and order rational numbers. So here we're going to look at example 1. So for example 1, we want to compare negative 1.2 or negative 1 and 2/10 compared to positive 8/10. On the number line, negative 1.2 is over here and positive 0.8 is over there, further to the right. So that means that negative 1.2 is less than positive 8/10. So what symbol goes in the circle there? That's going to be a less than, right? So did I really need to put this on a number line? Because one's positive and one's negative. So you don't even need to look at a number line to compare those. Does that make sense? All right. Now, here we have a negative 1 and 40/100 and a negative 1 and 25/100. Here, we're going to graph the decimals on the number line. And this is a vertical number line, okay? So, when we graph these on the number line, down here is negative 1.40, negative 1 and 40/100. And then right here is negative 1 and 25/100. On a vertical number line, of course, the lower the number is, the further down on the number line, then that's the lower the value. The higher it is on the number line, the higher the value, right? So, what symbol goes in here? That's going to be a less than. Very good. Now, I want you to notice up here that we have the decimals there. They're both to the 10th place, right? They're both to the 10th place. Here, These decimals are both to the hundredths place. Those are both to the hundredths place. When you are comparing rational numbers, they have to be to the same place value. When you have decimals, you have to have it to the same place values. Is everybody clear? Now, what do you think happens when we have fractions? We have to have common denominators. Very good. So here, what's the common denominator with 8 and 16? 16. Very good. So we need to change the -3/8 to 16ths. So how do I change 8 to 16? Times 2. Very good. So here we're going to multiply the numerator and the denominator times 2. Okay? Please don't let me see you do this. Times 2. Because that means a completely different thing. Right? That means times 2 over 1. Right? So we don't want times 2 over 1. We want times 2 over 2. Got it? So now we end up with -6/16. So if this one is -6/16, now we have common denominators. All you have to do is look at the numerators. So that's a -6 and that's a -5. What symbol goes in the circle? That's going to be a, remember, the bigger the number, with both negatives, the bigger the number, the smaller the value. So this is going to be less than. Very good. All right, so for the got it problem A, we want to compare 3 1/10, and we want to compare -3 7/10. Well, we see that they're both to the 10th place, right? But more importantly, we see that one of them is negative and one of them is positive. So do I need to do any work here? No. What symbol goes in there? Greater than. Because the positive numbers are always greater than the negative numbers. Very good. All right. So how about -4 1/2, 4 5/10, and -4 49/100? Now, this one is to the 10th place. This is to the 100th place. Remember we said we want to have them both to the same place value, but we want them to be to the greatest place value. Okay? So if I want it to go to the greatest place value, what do I need to do to this -4.5? Add a 0. Very good. So now we have -4 50/100 and -4 49/100. Now they're same and same, apples and apples. Now we can compare. Okay? So remember, they're both negative, right? So the bigger the number, the smaller the value. What symbol goes in this circle? Very good. That's going to be a less than. Because 50 compared to 49, 50 is bigger, right? So that means a smaller value. You see? Good. Very good. All right. Now, for example C. Piece of cake, right? Because it's already got common denominators. So that means the only thing we need to look at to compare are the numerators. So what symbol goes in there?
Less than.
Less than. Very good. Less than. Excellent. All right. What do I have to do with problem D? We need to get common denominators. Very good. Why don't you guys do this one on your own? All right. So there is problem D. So once again, we have to get common denominators. So we had to 10 with 10 and 5. 10 is the common denominator. So we're going to multiply the numerator and the denominator of the 4/5 times 2, and we end up with -8/10. Now, we're just, because we have common denominators now, all we have to do is compare the numerators. So we have -7 compared to -8, The bigger the number, the smaller the value. So that's going to be a greater than in the circle. So now we are going to compare and order rational numbers. Now remember, rational numbers are all of the numbers that you can write as fractions a over b, right? Now to compare and order rational numbers, the first thing you need to do is write them in the same form. And just like I've been saying, just write apples and apples, right? They just have to be all the tenths place, or all the hundredths place, or all with common denominators, right? So they all have to be in the same form, okay? They have to either all be fractions or all be decimals. You got it? Okay? So let's take a look at example 4. So, for example 4, we have a negative 0 and 51 hundredths, and we have a negative 8 fifteenths. So here, the first thing we're going to do is we're going to rename the fraction as a decimal, okay? So when we make that fraction into a decimal, here is what the result is. And you guys will show that work as long division on the side. So now we have a negative, oh, that's not the color. We have a negative 0.53. There's a negative 0.53 right there. And then we have the negative 0.51 right there. So when we compare them further to the left on the number line, smaller the value, right? So what symbol goes in here? That's going to be a greater than. Very good. For example 5, we want to put this set of data in order from least to greatest. Least to greatest. So the first thing we're going to do, just like what they said in example 4, is we're going to write them all as decimals, okay? And because the decimal that's given to us right here is already to the hundredths place, we want to write the rest of them to the hundredths. So here, when we do the long division, you would divide 22 divided by 25, right? Let me show you something here. So we want to make it to the hundredths, right? So that means that the denominator of this fraction right here should be 100. How do I make 25 into 100? Times 4. Very good. So if I multiply times 4 here, and I multiply times 4 here, am I going to get, what am I going to get? 88 over 100, right? So that's going to be negative 2 and 88 hundredths, which is what we have right here. Is everybody clear? Does everybody see how I did that without doing long division? Okay? I'll do another one. Here I want the denominator to be 100. Is everybody with me? So this right now, it's a 10. How do I make 10 to 100? Multiply it by 10. 10 times 10 is 100, right? So if I multiply 10 in the denominator, I have to multiply by 10 in the numerator. So this is going to be negative 2 and 10 hundredths. Is everybody with me? So this is negative 2 and, oh, this is just a tenths. How do I make it to a hundredths? Add a 0. Annex your 0. So now we can compare our decimals. So we're going to compare the negative 2 and 88 hundredths. We're going to compare the negative 2 and 10 hundredths. And we're going to compare the negative 2 and 46 hundredths. There they are on the number line. So in order from least to greatest, we've got negative 2.88, which is negative 2 and 22 25ths. Then the next one is the 2.46, the 2 and 46 hundredths. That's already a decimal. And then lastly, we have the 2 and 1/10. Here's the 2 and 1/10 right there. Okay? Is everybody clear? Now, please note that when you write your final answer, you do not write the decimal that you changed it to. You write the original number. So let's fill in, let's do some got it's here. We're going to fill in each circle with a less than, greater than, or equal to make a true statement. So, for example, E, we want to change everything to decimals, right? And we want the decimal to be out to the what place value? To the thousands. Very good. So here, I am going to separate my integer and my fraction. So I've got -3 and it's going to be a decimal because remember, and means decimal. So this says -3 and 5/8, so that's -3 and, so -3 point. Is everybody clear? And now I'm just going to divide the fraction part. So that's going to be 5 divided by 8. Please make sure you know which one is the dividend and which one is the divisor. Okay, so now you can add your decimal and bring it straight up and then annex a 0. How many times does 8 go into 50? 6 times. Whoops. 6 times. 6 times 8 is 48. And then we subtract and we get 2. So let's annex another 0 and bring that down. So 8 goes into 20 2 times. Very good. 2 times 8 is 16. And then we subtract. And then we annex another 0 and bring that down. 8 goes into 40 5 times. So 5 times 8 is 40. And now there's a 0 remainder. So this is going to become -3.625. Very good. -3.625. So now, what symbol goes in there? Very good. Very good. You got it? All right, let's look at letter F. Now, letter F, we don't have to separate any integers or whole numbers. We just do the division for 3/7. So we're going to divide 3 divided by 7. Now, what do we want our decimal to be out to? Thousands. We want it to be out to the thousands, right? So, if I have to round to the thousands, then I have to go out to the 10,000s, right? Okay. So, let's add our decimal, bring that straight up, and then annex a 0. How many times does 7 go into 30? 4 times. 4 times 7 is 28. And then we subtract. So that's going to give me 2. Annex another 0. Bring that down. 7 goes into 20. 2 times. 2 times 7 is 14. Good. And then we subtract. 6, right? Annex another 0 and bring that down. How many times does 7 go into 60? 8 times. Very good. So now this is at the thousands. The thousands, right? So because we want to round to the thousands, we want to go one more, right? So we're going to annex another 0 and bring that down. And how many times does 7 go into 40? 5 times. So 5 times 7 is 35. We're just going to finish our division here. And now we've got 0.4285. We want to round to what? To the thousands place. So here's the number in the thousands place, right? So the next number tells me what to do. What does it tell me to do? Round up. Very good. So this is going to be just 0.429. So what symbol goes in here?
Greater than.
That's going to be a greater than. All right, so problem G, we want to put the data set in order from greatest to least. Now look, this greatest to least, right? Now, we want to change these all to decimals, right? What's the greatest place value is going to be? The hundredths. We want this all to be the hundredths. Oh, but what do you notice here? And the fractions have denominators that are multiples of, or factors of 100, right? So, we can just do that little trick. Well, this one over here is real easy, right? Because that's already negative 7 and 1700ths. How do I write negative 7 and 1700ths? Very good. Negative 7.17. So that one's a piece of cake, right? So now we just need to change this one. And I'll do that down here. So we have negative 7 and 13/20ths. Now, how do I change 20 to 100? Multiply by 5. Very good. So you're going to multiply by 5 in the denominator. And if you do that in the denominator, you have to do it to the numerator. Very good. That's supposed to be a dot there. Okay. So, when we multiply straight across, this is going to give us negative 7 and 65 hundredths. Very good. So now, this is my fraction, negative 7 and 65 hundredths. How do I write that as a decimal? Go ahead. Very good. Negative 7.65. So now, all I have to do is compare my decimals, right? So, we're going from greatest to least. Don't forget, here, don't forget that we are, when we're going from greatest to least, with all negatives, the bigger the number, the smaller the value, right? All right. So, the bigger the number, the smaller the value. So, which one is the biggest number here? I mean, this has the biggest value here. 7.17. Right. 7.17 goes first because it's the smallest one. That means it has the highest value, right? What's next? 7.65. And then finally we have, very good. Now, when we write our final answer, we're going to write our original numbers, right? So, we've got negative 7 and 17 hundredths. We've got, what comes next? This one right here. Very good. And 13 hundredths. Very good. And then finally we have the decimal, which is negative 7 and 78 hundredths. And don't forget to close your brackets. Yes, good catch. So this was actually negative, this one right here, good catch, was negative 7 and 13/20ths. Good catch. So, example 6 says Mr. Plum's science class is growing plants under different conditions. The table shows the difference from the average for some students' plants. Order the differences from least to greatest. Okay, so if I'm going from least to greatest, and I have some positives and negatives, I'm going to compare the negatives first, right? So, the negatives are right here. Keeping in mind that the greater the number, the bigger the number, the smaller the value, right? So, we have a negative 2.2, there's that one. And we have a negative 1 and 7/10. So 1 and 7/10 written as a decimal is right there. So when we put those two in order, first comes the negative 2.2 and then comes the negative 1 and 7/10. Is everyone clear with that one? And then we can compare the positives. Okay? So 3 and 1/4 becomes 3.25, and 1.7 is just 1.7. So the next one is the 1.7, and then finally the 3 and 1/4 right there. Now, I do want you to make sure that you go through the motions of changing the fractions and the mixed numbers to decimals, okay? But if you look at this 3.25 and this 7, can you tell just by looking at which one is the smaller one? Because one's a 1 and the other one is a 3. Does everybody see that? Okay, but I still want you to, at this point, to go ahead and change to decimals, okay?